Today we're going to talk about line of best fit. And lines of best fit have to do with scatter plots, so make sure you understand scatter plots before you continue. We're going to start with some data from a local ice cream shop that kept track over 12 different days of how much ice cream they sold versus the temperature outside that day in Celsius. Looking at the table of data, you can get a little bit of information from the table and a little bit of understanding about the data. But of course, if we put it into a scatter plot, it's much easier to understand. Now we can see that there's a general trend to the data that says the warmer the weather is, the more sales we're going to have from an ice cream shop. The relationship's not perfect. There is a positive correlation to this data, but remember, having a certain temperature outside doesn't guarantee an exact number of sales. So we're going to bring something called the line of best fit. The line of best fit is sometimes called a trend line, and basically it's a line that follows your data. In order to have an accurate line of best fit, you need to try to have the line as close as possible to all the points on your graph. Basically, the line needs to go through the middle of your data, and try to have as many points above the line as you do below. Quite often, to draw a line of best fit, people will pick 2 points, like this person picked this point and this point, to draw their trend line through, that kind of indicate where the middle of their graph is. Now, line of best fit is not an exact science. Everybody's line of best fit could be a little bit different. For instance, what if I had picked this point that's just off the line and maybe this point up here? My line of best fit would be close to the one I have now, but not exact. So kind of keep that in mind. Unless you have a perfect correlation, line of best fit is not 100% exact. Now, line of best fit is used for a lot of things, but one of the reasons we have to have 2 points for the line to go through is eventually we're going to have to find the equation of that line. So we're going to take those 2 points. It looks like the first one is just beyond 16, and the second one is very, very close to where x is 25. So looking back at our data, we can find those 2 data points. And now we're actually going to use our skills for writing the equation of a line that passes through 2 points. The first thing you have to do is find slope, of course. y2 minus y1 over x2 minus x1, and I get an approximate slope of 33.2 when I round to the nearest tenth. Then I'm going to pick one of my 2 original points, and now I have an m for slope, an x, and a y from my point. I'm going to use slope-intercept form. Remember, this isn't the only way to write the equation of a line through 2 points, but it's a good one. And I'm going to plug in my m, x, and y so that I can find my y-intercept of b. Multiplying m and x, and then subtracting 544.48 from both sides, I get a b value of negative 219.48, and that's going to be our y-intercept. So then remember, we're going to take m and b, slope and y-intercept, and create a general equation for our line. Looking back at our graph, we're going to make sure that that line matches up with our line of best fit, but this is a little hard because our x-axis didn't start until 10. So let's extend that graph a little bit. And can you see now, the slope might not be easy to see. We can tell that it's a positive slope, but the y-intercept was negative 219.48, which looks about right. And that means that if it's 0 degrees Celsius outside, the ice cream shop's probably going to lose money, which makes sense because that's about 32 degrees Fahrenheit. And that's freezing, so it's pretty cold. Not a lot of people are going to want ice cream. A good line of best fit, and this is mostly what they're used for, allows us to make predictions about the data. For instance, we can predict the amount of ice cream sales made when the temperature is 30 degrees Celsius outside, which is about 86 degrees Fahrenheit. We can put 30 degrees in for our x value since that was our x-axis. And solving or simplifying, I get 776.52, which means that when the temperature outside is about 30 degrees Celsius, I can expect around $776 in sales. Again, scatter plots and trend lines are not exact. I'm not guaranteed that amount of sales when it's 30 degrees outside, but I can estimate. Scientists use this type of estimation all the time. For instance, this is a scatter plot of average sea level for many, many years. When scientists draw in a trend line or a line of best fit, they can use that line to predict what the average sea level will be in any given year. So let's say they wanted to predict what the sea level was going to be in 2030. They can use the trend line and the equation of the trend line to make that prediction. You've seen this chart before when we talk about correlation and positive versus negative correlation. If you have positive correlation, obviously your slope or your trend line is going to have a positive slope. The higher your correlation is, like with a perfect positive correlation, the more accurate your line of best fit will be. It's pretty easy to find a line of best fit in a perfect correlation or a high correlation. A low correlation, low positive or low negative correlation, it's a little more difficult and it will be a little less accurate, but it's still very doable. The only time we can't find a line of best fit is when we have no correlation at all. So let's do just a little practice. All four of these graphs are exactly the same scatter plot, but which one shows the most accurate line of best fit? Remembering that you need about as many points below as you have above, the correct answer would be D. How about this scatter plot? Again, all four graphs are the same. Which one shows the most accurate line of best fit? And that would be graph A. Last but not least, what would the line of best fit look like for this scatter plot? This data looks very much like an exponential function, and sometimes you will have lines of best fit that are exponential. Now, you need to know how to draw a line of best fit and how to find the equation of that line. That's our goal today. There is a way to make this happen on a graphing calculator, so after this video, I'm going to post a video on how to use a graphing calculator to find the equation for the line of best fit from a table of data. But for now, I'm going to wish you a very good day, and I'll see you next time.